and welcome to the videos for lesson 12. Today we're going to be talking about a lot of plotting. So this lesson is going to be divided into 3 different parts. We have first a review of plotting concepts that we've learned so far, plus a couple of new functions. Then we're going to get into 2-dimensional plotting and finish off with mapping with Cartopy. I suggest that you take breaks between these videos and take care of yourselves along the way. And we're going to jump right into a review. So first things first, we're going to talk about how we create a figure. Remember, there's a couple of different ways to do that. You can say fig equals plt.figure, or you can say fig, ax equals plt.subplots, and then you give it a number of rows and a number of columns. Subplots, remember, you are creating multiple axes objects on a figure, whereas this one just creates a figure. And if you actually want to create an axes object to go with that and have that axes object variable name, you can do that by saying ax equals plt.axes, and that will create an axes for you to work with, even if you're not in a subplots a function there. You can also call the axes that is currently being plotted on using the code plt.gca. We talked about that a little bit in the previous video. So the first kind of plot we learned about was a basic line plot, and you have plt.plot. Remember, you can replace this plt with ax if you have an axes object, but the function is plot, and we have to give it an x and a y for our data. And then all of these are sort of these optional formatting arguments. So we have color, and the input for that is a string. Line style, again, the input is a string. Marker, and that's the marker shape, and that's just a string as well. And then we also have marker size and line width, both of which can be floats, and those are sort of the sizes of things. These things, we talked about this in class on Tuesday, you can actually combine into one sort of sneaky shortcut, where you can just combine it into one string here. You don't actually have to put an argument in front of it, but you can only do that if the color is one letter. So if you are using just a color that's an identifier that's one letter, so you have R for red, G for green, that kind of thing. Which means that you can kind of look at all of these formatting tables that are on the documentation for Matplotlib, and you can see these are all of the different markers, these are different line styles, and these are the one-letter characters that are supported. There are also a number of non-one-letter characters. Those are words, like salmon or Rebecca purple or whatever. But those ones you can't do that shortcut with. So if it's just the one letter, you can do the shortcut. If not, you have to denote it with a C equals whatever color you're using. So just an example, I've created a little bit of data here, 1, 2, 3, 4, 5, 6, and then y is just those values squared. So it's a quick quadratic. And you can see we have our example that I was showing earlier. It's the color is red, the line style is solid, the marker is an O, and the marker size is 5 with a line width of 2. Now when we change those things, you can see we get a blue, and we can show that the line is now dashed in there, and the markers are squares instead of circles. And my marker size is a little bit bigger than those. And then our line width is quite a bit smaller. So you can customize pretty much anything you want. The next thing we learned about was a scatter plot. Remember, a scatter plot is just showing the x and y coordinates. It's not connecting them. PLT, remember, you can also replace with ax, and it's dot scatter. You give it x coordinates and y coordinates, and then you can do all the formatting things. So we have size and color, and those are just a little bit different from your line plots because you can give it an integer, or you can give it an array. Same thing with color. You can give it a string, or you can give it an array. When you give these things arrays, it actually allows them to be variable. So you can have sizes that are different, and you can have colors that are different in your markers. Yeah, and then you have your marker, which is the same as the line plot. And then you also have line style, line width, and edge color. And even though there's not a line connecting the dots, there's still a line that you can format. And I'm going to go over that really quickly. So here we have our same little quadratic data. And I've created a Z just to create a little bit of color for one of these plots here. But you can see I have X and Y, and then I do constant size, just one color, O for a marker. And then I say a line style is solid, but you can't see any lines connecting these. And what that line actually is, it's the line around each of the markers. So you can see it's a solid line around these markers with a line width of 1 and an edge color that is black. Now, normally, if you don't designate that edge color, it's just going to be the same color as the face of it. So, it helps things pop out a little bit. So that's something that you can customize. And now if you go over here, you can see that I still have a constant size, but I've changed my color And you can see the color actually does change as Z increases. You get sort of a dark blue to a yellow. And you can see my mark is the same, but my line style is now dashed. And you can see the dashes are around each of these circles here. So you can see that's sort of the change that happened between here and here. And you have the line width of 1 and again the edge color of black. So now that we are creating multiple colors on a plot, we have to consider what those colors mean and be able to tell whoever's looking at this plot what that means, right? So here is just a slight adaptation of that previous code. And you can see it, I've now created an axes object, and I've given my plot a variable name. And doing that allows me to create a color bar that is tied directly to those things. So you just say plt.colorbar, and you give it the plot variable name. In this case, it's scat, and you give it the axis, which in this case is ax. So that helps tie it to that, and you can see that it goes from 0 to up above 200 there. So what happens if you want to change the color? Well, you can do that using color maps. So here we have our original, and this is sort of the default color map. But in your plt.scatter, if you designate a C map equals a string that corresponds to a color map, you can see you can change the color here. One thing I want to point out is that if you change the color map to something that has a white on one end and you don't have an edge color around it, you actually won't be able to tell it's there because the background is also white. So that's something to look out for and be cautious of when you're using color maps. In order to find all the different color maps, you can follow the documentation. I believe we asked you to do this in assignment 3, so I'm not going to go in and dig in there. But I suggest you look at it. There's some really great colors, and go ahead and just play around with a simple plot and see what different colors you can enjoy. The last thing that we most recently learned was a histogram. So we have the function is plt.hist, and we give it the data. And what it's going to do is it's going to count the number of times that that data happens. And then we have all these customizable things. So we have the number of bins, or you can give it also bin limits. And we're going to talk about that in just a second. But then you can give it the color, you give it the edge color. So you can actually put boxes around your boxes that make them pop out a little bit. And you can also do an R width. That's not here, but we talked about it. And you can give it an alpha, which is the transparency, right? So you can see how much it sort of is see-through. So let's go through an example. We have the World Ocean Atlas temperature data set from class 11 activity. And I've just opened it up and grabbed my temperature data and flattened it out in order to have all the data in one thing. And here I created my figure and I do my histogram, and you can see I do bins of 100. I do my relative width of 0.6, a blue color, an edge color of black, and you can see a 0.5 alpha, and it's a little bit hazier. And then you compare it to this where I've actually just changed the alpha, and you can see this is a little bit more solid. So basically, it's just sort of plotting how transparent these things are. Now we're going to talk a little bit about doing bin edges rather than just the number of bins. So this one, it just has 100 of bins. It doesn't matter where those bins line up. They just sort of line up however many there are in your data. If you wanted to actually designate where those bins line up, so say you wanted to see how many temperatures between 0 and 1, and then 1 and 2, and then so on and so forth, you would actually do something like this, where you can say bins equals range of 0 to 31. So that's going to be 0, 1, 2, 3, and it's going to give you the temperatures between each of those values in here. So you can see there's actually just going to be 30 boxes here, and you can see the edge color, it's black, and you can sort of see it on the edge around there as well. So that's just something a little bit different for histograms, and sort of an interesting thing to work with that might be helpful for research and science. That's all I'm going to talk about for this review. Next, we're going to get into a bit of 2D plotting, and I will see you then.